Hello again and welcome back. Thank you for joining me as we're going to spend some time today talking about a service that I enjoy working with within OpenStack, and that is the orchestration service, codename Heat. Heat is something that I've enjoyed working with for quite some time. It was introduced back in Havana and Icehouse days. And to me, it adds a great number of capability and features to your OpenStack cloud. It allows you to warm up to the idea of writing automation code in reference to your cloud platform. Many of you who know me know that I often call this the DevOps with training wheels. And for those of you who are exploring doing automation and interaction against your OpenStack cloud, Heat is definitely a place that you can start to kind of get warmed up to that idea and shake out some best practices for yourself. So what you're looking at on the screen here is my lab environment. I deployed OpenStack, the Mataka release. I always deploy OpenStack using OSA, which is OpenStack Ansible. That's my preferred method of deploying OpenStack. And what you get with that is that, as I've mentioned many times before, is that the OpenStack services are actually deployed inside of LXC containers. And that's to allow some segmentation between the services as well as ease of upgrade when it's time to move on to that next release. And what you'll see here is that I've listed out the containers running on my lab environment, and there's two containers in particular that we want to draw attention to in reference to Heat. We have the Heat API container and then the Heat engine container. And obviously the Heat API container is self-explanatory. That's where the code or the service that runs the Heat API exists. Now, the Heat engine container is actually where the brains behind Heat exists. Those Heat templates that you create, or hot templates that are created, Heat orchestration templates, are actually executed by that Heat engine. And the Heat engine manages all of the code in there and making sure to find the resource types and doing the tasks that you've assigned to do in that Heat template. So Heat engine is actually the brains behind it. One tip about the Heat engine is that you can actually control through the config file how many instances or processes of that Heat engine actually spin up. And you can throttle that up and down based on the use of your cloud. If you have a lot of consumers using Heat at one time, you may find that you may need to bump up how many Heat processes are running so that it can execute those templates in a timely manner. But that's just a very quick takeaway there. So before we move too much further, let's actually explore Heat from the Horizon dashboard. It kind of gives you a visual as to what you're doing there. And then we can maybe go and explore what you would do from a command line aspect as well. So before we do that, we actually need a template to test with. And what I have up on the screen here now is a Heat template, a very simple Heat template, so much so that the description matches it perfectly. It is a hot template that creates an instance and attaches a send and volume to it. Very simple, very straightforward. And I wanted to start with something simple because I felt it was important to first wrap your mind around the concept of Heat, and then you can get into more difficult things. So first thing we've done is we've defined some parameters, and parameters are just like variables that you would put inside of your code that you may write. They're basically placeholders, right? They're placeholders to you to give it a value so that when you execute this Heat template, you don't have to change your code every time. You would just change whatever you provide as far as a parameter. So we're going to provide a key name, a flavor, an image, a network attached to, and of course the volume size. And then after that, you really quickly move on to the next piece of your hot template, which is where you define your resource types. And we've defined 3 different types of resource types here. One to be able to create the actual instance, calling Nova. One to actually create the actual volume, calling Sender. And then last but not least, actually telling Sender to attach that volume to the instance that we created above. And then at the very end, it gives us an output of the IP address of the instance that we created, just in case you wanted to tuck that information away and store it. Again, this is just a very simple, very quick example of what a Heat template looks like. And now we're going to actually execute this template and see it in action. So we're going to move on to the next tab here where I have my lab environment that's running through the Horizon dashboard. And basically, to find the orchestration service inside of Horizon, you're going to expand project. And then underneath there, there's going to be a tab called, or a menu item called orchestration. And if you expand orchestration, there's two items that are listed in here. Very quickly, just kind of wanted to jump in and show you resource types. If you were able to read the blog that I wrote in conjunction with Heat here with just this past week, you'll find that I referenced being able to review the resource types you have available in your cloud. The resource types that are available are based off of the release of OpenStack that you may be running. And I recommend that you go in and take a look and inventory of the resource types you have available in your cloud, primarily because you want to make sure that when you go to write your Heat templates, you're referencing a resource type that you actually have available in your cloud. Just because the resource type is available on the openstack.org site as far as possibly something you can use and call does not mean that that resource type is actually defined within your actual OpenStack cloud. So I definitely recommend coming in here, taking a look at the resource types that are here available, and make sure that the resource type you want to use in your Heat template is actually listed here. So now jumping over to the next piece of the puzzle, which is stacks. So within Heat, when you actually define a Heat orchestration template inside of your OpenStack cloud, it is then defined as something that's called a stack. And all a stack is basically an executed Heat template. And it will tell you the status of your stack, whether it completed successfully, whether it failed. You can do things such as suspend a stack, snapshot a stack, delete a stack, of course. So there's quite a few things that you can do within the Horizon dashboard around your stack, as well as the neat feature of being able to preview a stack. And this functionality is that if you wrote a Heat template and you're not sure exactly if it's going to work or not, you can actually do a stack preview. If you click on that, if you give it the file that you want to preview, it will go through and evaluate whether or not that template is configured properly. And if I give it a name here, I'm just going to call it test and do preview, you'll see that there was something that it was looking for that I didn't give it. And that was actually a really good test to show that there are parameters that need to be provided to the template. So when you have a template that needs parameters, you need to be able to provide that environmental file. So we're going to move past that, and we're just going to launch this stack and give this Heat template a go. So the template that we were testing with is called VM with sender. We're going to open that. And in this occasion, I'm not going to use an environment file, which is basically a file that has pre-populated the values of the parameters that you need to feed into the Heat template. I'm not going to use an environment file here because I want you to see what the next screen looks like when you don't have an environment file. So if I hit next here, you'll see that it comes up with a list of menu items that I need to provide values for. All your stacks need to have a name. The name is trivial. It does not have to be associated with anything with your stack, but you definitely want to name your stack something that you, will make sense to you when you go to reference it later. So I'm going to name this stack VM with volume. And I'm going to provide the admin password. You do need to provide a password for the user that you're using when you execute this Heat template. And that's because it will actually go off and be able to do administration things later. Let's say, for example, if you want to add or update that Heat template, it will actually store that password so that when it goes and make those functions later, it will actually be able to authorize itself against Keystone to do it. I'm going to select the flavor that I'm going to use. I'm going to select the image of the VM that I want to, of the instance I want to create. I'm going to select the key pair name. And last but not least, I'm going to give it the network name that I wanted to attach to, and of course volume size. So I'm going to make a volume size of 10 gig. So if we're ready to go, we're going to hit launch here. And what we should see is that it should begin creating that stack where it says a create in progress. Now if you click on that stack and go on to the next screen, you'll actually be able to see this little dynamic picture here that actually shows you the progress of the stack being created. And as the things shake and turn green, that means they're done. So the instance was created successfully, we've created our volume successfully, and finally now we've attached our volume to that instance. And if we go look at the overview really quickly, it is basically a snapshot of what you did, how long it took to execute, the name of the ID and the name of the stack you created, as well as the output. Remember the output that we added to provide us, which was the IP address of the volume we created? You can see your output is listed here as well. And it also captures some other interesting information, such as the values of the parameters that you provided when you executed that stack. This is always here and will exist as long as the stack is created. You always have this information to refer back to. So now if we jump over just to validate that our stack created the resources that we expected, if we go and look at our instances, we should now see an instance that was created with the image that we created, with the size we created, and as well as the key pair. And the most important thing is we'll note that it's active. And then if we go under the volumes tab, as well, you'll see that there's a volume that was created that's 10 gig. You'll see that it's attached to the instance that was created, and all is well. So again, this was a very quick, very brief example of how you can leverage Heat. A very simple example of what you can do with Heat. There's many more complicated things you can do, such as spinning up multiple instances and attaching them to different networks, as well as attaching them to load balancers and the creation of users, creation of projects, creation of roles. Anything that you can do within your OpenStack cloud, you can actually automate into a Heat template, which to me I think is a very a nice piece of functionality. So now that we spent some time dealing with Heat in the Horizon dashboard, I figured we would flip over now and try and execute a Heat stack from the CLI. And what I've done is I have my command window up here, and I've attached or jumped into the utility container. And if you're not familiar with the utility container within OpenStack Ansible, it's a container that's created out of the box that has all the OpenStack services CLI configured and installed there already. So it makes it a very convenient place to be able to run your CLI commands from, as well as you can leverage this utility container when you're writing your automation code, when you want to execute CLI commands using tools such as Ansible, Chef, or Puppet, or alike. So now that I've jumped into this container, I've sourced my OpenRC file. That way I'm able to authenticate and authorize against the OpenStack services. And then I moved into a directory where I have my Heat template stored. And there's two files in that directory. The first being the Heat template itself, which is called Heat CoreOS Beta. And then the second file is actually the cloud config that I'm going to pass when creating their CoreOS instances. And if you're not familiar with CoreOS, it requires that you provide a cloud config when creating the instances there. So we're going to supply that cloud config as well. And if I was going to create this Heat template into a stack on my environment, the command to do that would look something like this. And if we take a second to evaluate the command a little bit and be able to break it down, I think it'll be really useful. So at the very beginning, we're going to call the Heat CLI by just calling it Heat. We're then going to execute the command of a stack create. So that's just stack-create. We're going to give that stack a name, which we're going to call CoreOS. And then after that, we're going to feed in additional parameters that we need to pass, as well as naming the template file itself, which is called Heat CoreOS Beta. So we're going to pass in the necessary parameters, such as the key name, the user data, which is that config file that we are referencing up above there, the name of the stack, as well as, not the name of the stack, but the name of what we want to call the instances. And then as well as, last but not least, providing the network name for the instances that we're going to create, that we're going to attach those instances to. So if we're ready, we can actually hit enter. And what happens when we hit enter here is it'll come back with the status as to what happened with that stack. So it's in a create in progress status. And if we execute the command heat stack list, we should then see either that is still creating, which it is, which is actually a very positive thing. And if we execute that heat stack create again, now we'll notice that the stack is complete. And if we want to see some details about the stack, we can execute the command of heat stack show and just provide the ID for the stack we just created. And what it's going to do is it's going to give us the same level of details that the Horizon dashboard gave us when we reviewed the first stack we created. Very pertinent information such as when it was created, the description, the name of it, the ID, the parameters that were passed when creating that stack. And if we had any specific output that we wanted to write, the output would be listed there. In this occasion, we didn't choose to write any output. But again, if we did, it would also be listed there just as well. So to kind of validate, really pretty easy that it did what it was supposed to do, we're going to execute a few other CLI commands just to check to make sure it created our instances as we expected. So if I do a nova list command, it's going to list out all the instances that are running on my OpenStack environment. And we'll see here that we have 3 instances that were created, all named CoreOS, all active and running, and they were attached to the private network just as we specified. So again, a very simple, very concise example of how to use Heat, but very useful in a sense of showing all the many capabilities that it has. And I definitely recommend, if you have not started using Heat, I definitely recommend giving it a go. You won't regret it, and I think you'll find great success with it.